Hey all, welcome back. While designing my upcoming PC case, there were features on it that I struggled to find ways of replicating accurately by hand. These contours along the top panel were the culprit. This was not something I could do on my laser cutter either. The best method I could think of was to use a CNC. So I did my research and stumbled upon Anolex. They are not as well known as the mainstream desktop CNC brands, but their 3030-Evo Pro unit had a few critical things going for it. 1. All XYZ axes were on double linear rails. 2. The working surface is larger than a typical 3020 model. And finally, their pricing was very competitive. I then reached out to them for a review unit and thankfully they agreed. The package came in a week and I began assembly immediately. Their manual was well written with nice pictures showing each steps. Assembly was relatively easy as the larger components were already pre-assembled. First, install the Y stepper motor. Don't forget to lock the lead screw coupler. Then we use this cool spacer tool to position the slot nuts. 2 pieces of their sample MDF is placed under these nuts to support the Z gantry. The Z-axis unit is then attached, followed by the spindle holder. Now we can slide the 300-watt spindle in place. The control board is mounted on the back of the Z gantry. There is some cable routing and management involved to connect the motors and limit switches. This was easy to follow using the provided manual. The completed unit feels very rigid and solid. Let's give it a test. Instead of using the provided clamps, I chose to use the masking tape superglue method to secure the sample MDF onto the bed. This removes the risk of accidentally colliding your bit with any clamps. Great news for a CNC beginner like myself. Let's start with one of the included V-carve bits. After setting the Z clearance with a piece of paper, we ran one of the included G-codes. Not bad for a first go. Included in the kit is also a Z probe, which is a much better way of setting the reference height. First, we have to accurately measure the height of the probe. Mine was 19.37mm. Now we can place the probe under the bit, clip the other end onto the bit and hit the probe function. The CNC will slowly descend until it touches the probe surface and detects an electrical continuity. Then we can enter the probe height measured in the software and the machine will now know exactly how far away it was from the work surface. I tried a few more engravings with the new setting and they came out nice as well. Let's move on to some cutting. This O-flute bit will be used first. Something I noticed was that the sawdust made it hard to see what the machine was cutting. So I designed and printed a fan that slides onto the bits to blow away the dust. I slid the fan on and was ready to try the cut on some pine. That's when it happened. I wasn't sure why or how, but when I hit start, the bit plunged directly into the wood and snapped. My guess was that I moved the 0 position of the head before starting the job and I did not reset it. Anyways, I put in a similar spiral downcut bit and ran the test again. You can see the fan works well at keeping the cut area clean and visible. Is it just me or does anyone else find this mesmerizing to watch? Maybe I'm just weird. Now onto something bigger. First, I glued down a temporary spoil board to protect the aluminium bed. Then a walnut block is glued on. We reset the Z height and start the cut. Now this may seem slow, which it probably is as it's only a 300 watt spindle, but Anolex also offers a 65mm spindle holder which can accommodate the popular 710 watt Makita trim router, which would speed up the cutting greatly. Regardless, this entire box took 38 minutes to machine, which may sound long, but imagine trying to replicate this manually with the same amount of precision. All of a sudden, 38 minutes doesn't sound very long to me. After the bulk of the material was removed, a single full depth pass was used to clean up the inner surface. Followed by cutting the outer surface. To finish off the box, I swapped in a chamfering bit to give the edges more detail. But here's where I did another mistake. I hit record when the camera was already recording, so it stopped the recording and I don't have any footage of the chamfering. Anyways, this is how it looked directly off the machine. There's a notch where the chamfer bit plunged in to reach the bottom, which I programmed incorrectly. Still looks great though. I then gave the bottom edges a chamfer as well, followed by a coat of food-safe wax. Beautiful. Let's put it to use. Time for some lunch, I think. So far, I'm really happy with the CNC and can't wait to use it on the next PC build. Make sure you're subscribed so you don't miss that video. A huge thanks again to Anolex for providing the unit for review, and a big thanks to you guys for watching till the end. I'll catch you in the next one.